Hi guys, welcome to the channel. In this video we shall discuss a new concept called sign convention for spherical mirrors. I think all of you know the graph which has x-axis, y-axis, right? All the distances measured along right side of the origin are considered positive and left side are considered negative, right? In the same way, all the distances measured above the origin in the y-axis are considered positive and below the origin are considered negative. Okay, so that graph is also known as Cartesian plane. Okay, so here we are going to deploy one convention called a new Cartesian sign convention. It is used for measuring various distances in the ray diagrams of the spherical mirrors. Okay, so we need to follow some rules and regulations in this. So I want you to understand those rules, right? So here there are 5 rules are there, and there is figure 44 is there. Suppose a mirror is kept in such a way that the pole of the mirror is exactly equal to the origin of the graph. Okay, so here a mirror is kept. It might be a concave mirror or convex mirror. Now the pole is kept in such a way that it is coincident with the origin. Okay, now what is the first rule? Please look here. The first rule is that all the distance are measured from pole of the mirror as origin. Here pole should be taken as origin, and all the distances, whether it is left side or right side or upside or downside, you have to measure all the distances from the pole because pole is the origin. Second one, the distances measured in the same direction as that of the incident light are taken as positive. Okay, so whatever the distances you measure from the incident light, they are all taken as positive, and the distances measured against the direction of the incident light are taken as negative. So here the second point and third point, it means that the object should be always kept left hand side, and the distances which you are measuring at the left hand side from the pole, they should be taken as negative, and the distances if you are measuring the right hand side, then they should be taken as positive. Okay, so right hand distance are taken as positive and left hand distance are taken as negative. Okay, so distance measured upward perpendicular to the principal axis are taken as positive. So just like the y-axis, distances are taken as positive, and the distances measured downwards and perpendicular to the principal axis are taken as negative. Okay, so these are the 5 rules related with the sign convention for the spherical mirrors. So here one thing you need to understand, that the object is always placed on the left hand side of the mirror. It's always placed on the left side. Okay, so this is the convention, right? So there are some important conclusions also here, right? Yes. So here one more thing is there, that is all the distances measured from the pole of the mirror to the right side will be considered positive. This I already told. Okay, so let us see some important conclusions. The object distance is always negative. This is first conclusion. The object distance is always negative because the object is always placed at the left hand side of the mirror. Whether it is a convex mirror or concave mirror, the rule is that we have to place the object always at the left hand side. That is the first rule. Because you are placing the object at the left hand side, and the distance between the object and the pole of the mirror is object distance. Okay, and that will be negative because it is always placed at the left hand side. Now this next conclusion is that if an image is formed behind a concave mirror, that is to the right side, the image distance is taken as positive. Okay, if the image is formed right hand side, you have to take it as a positive. If the image is formed in front of the mirror, that is on the left side, then the image distance should be taken as negative. Okay, so in the convex mirror, the image is always formed on the right hand side. There are two cases. In both the cases, the image is formed on the right hand side. So therefore, the image distance for a convex mirror will always be a positive. Okay, and also the next conclusion is that, what about the principal focus of a concave mirror? Is it left hand side or right hand side? The principal focus of a concave mirror, it lies in front of the mirror. Okay, so it is left hand side. So therefore, the focal length of concave mirror is always considered as negative. So focal length is, if I say the focal length of a concave mirror is 10 centimeter, it means that it is a minus 10 centimeter. On the other hand, the principal focus of convex mirror is the right side of that mirror. So therefore, the focal length of the convex mirror is always positive. Okay, if I say 20 centimeter, then it means that it is a plus 20 centimeter. Okay, so I hope you understood these various conventions related with the mirrors. Okay, so once again, you just see this here. So this is the pole here, mirror here. Here object is placed, the first rule is object should always be placed on the left hand side, and all the distances measured towards the left are taken as negative. So therefore, the focal length of a concave mirror is negative, and in case of a convex mirror, the focus lies on the right hand side. Therefore the focal length is always taken as positive, right? So if the image is formed on the left hand side, then the image distance will be negative. If the image forms on the right hand side, then the image distance will be positive. Okay, if the object is of a height of 5 centimeter, then it will be plus 5 centimeter. Then if it forms an image which is virtual and direct, then it is going to form above the principal axis. That means the height of the object is positive. If the image formed is real and inverted, so real and inverted image always forms downside of the principal axis. Okay, so below the principal axis, so below the principal axis, all the distances we take it as a negative. Okay, so that height of the image will be negative if it is a real and inverted image. Okay, I hope you guys understood it. Thank you guys.